To use first and second derivatives to find and label the critical points of a function. Here's an example. Alright, we have f of x equals 4x to the third minus 6x squared. Step 1 on this is to find the derivative. And the first derivative on this is going to be 16x to the third and then minus 12x. From that point, you want to solve the derivative equal to 0, and clearly that's a 16 and not a 12. There we go. 16x to the third, then minus 12x. Set that equal to 0. Now it looks to me like we can factor out a 4x. So you're left with 4x squared and then minus 3. So if you set 4x equal to 0, you'll have 0 for an answer. And then if you set 4x to the second minus 3 equal to 0, you'll have 4x to the second equals 3, which is a good thing so that you don't have a minus sign on the right side. And then x squared equals 3/4. X squared would have to equal the square root of 3 over 4, and that's going to be plus or minus. I put a square symbol in here when I didn't need to. I can't erase that other than just marking over it. It's x equals plus or minus the square root of 3/4. This will equal plus or minus 0.866. The next part is to plug in 0 for the original function, as well as a positive 0.866 and a negative 0.866. When we plug in 0, we get back 0. What happens when we put in 0.866 to the original function and round the answer to 3 decimal places? So when you plug in your 0.866 positive, you get negative 2.25, and then negative 8.66, you get back negative 2.25. We need the second derivative so we can do some tests here, and the second derivative, remember the first derivative came out to be 16x to the third. 16x to the third, and then it is minus 12x. That's the first derivative. Now the second derivative comes out to be 48x squared and then minus 12. What you have to do is plug in your x value to each of those, or into this one, and if you put in a 0, what do you get back for this one? You get a negative 12, so that's going to have to be a maximum, and that falls into line with the W shape. Now if I plug in 0.866 into the second derivative, what do I get back? Okay, so we get back 23.998, and since that's positive, it's what kind of point? Minimum. So last, you have to plug in negative 0.866 into the second derivative, and what do you get back? You'll get back the same thing, 23.998, which means that one is going to be a minimum. So you can label your critical points off with the 0, 0, and call that a maximum. And then you'll have 0.866, negative 2.25. That one's going to be a minimum. And then you'll have a negative 0.866 and then negative 2.25. That one is also a minimum. Drop this one off. For this, you're going to find the first derivative, and that will be a negative 8x minus 6. Set that equal to 0. And come up with negative 8x equals 6. When you divide 6 by a negative 8, you get a negative 0.75. And you have to plug that back in for the original function. So it's negative 4 times negative 0.75 squared minus 6 times negative 0.75, and then plus 5. what you should come back with, if I remember right, is 7.25. 7.25. So your point is negative 0.75 and 7.25. To find out if it's a max or min or a point of inflection, you have to find the second derivative, and that is going to be a negative 8. And it's negative, therefore you use the opposite, so it is maximum.